Hi, today I'm going to explain about logistic regression and also explain cross entropy, which will be used as a cost function for logistic regression. So before moving into the logistic regression, and the reason why we have to learn about logistic regression is really simple, because before we want to know all of the distribution. That's why in my last video we calculated EM algorithm to identify all of the distribution from such data distribution. But in this case, it requires many parameters, because in terms of m-dimensional feature space, let's say basis function pi, then if it is Gaussian, which is mostly used in probability distribution, then it will be represented by P given class likelihood and P class which is prior. So here the number of parameters will be 2m for mean values, and in case of covariance it will be m plus 1 over 2, because if there is m components, then because covariance matrix will be symmetric, so we have to know all of this term. So it will be m minus 1 and finally 1 if we sum everything, and the formula will be this one. Therefore we have to calculate m plus 5 over 2 and plus 1. It comes from 1 is coming from class prior. So there's a lot of hyperparameter, especially when the dimension is really high. And normally whenever we are dealing with machine learning projects or task or any statistic problem, then m is high. So in terms of logistic regression, we are just calculating what we want, the point that we have to calculate, which is a posterior probability, and that is P one class given data. So it is going to be explained just a function like this, or probability, and it will be represented as like this. So here this is a logistic sigmoid. It will have the value from 0 to 1, therefore it is appropriate to represent probability. And here we have W, which is weight. It has only m dimension. Therefore, it will be it recurs only m. So it is really efficient when the dimension is really high. And then, then we now can understand what is probability, how we can calculate probability, derive probability by just finding some weights. So that means it will be, in this case, linear, or even the hyperplane, it is still linear, multiplied by some basis function, or you can just think this is the input, or I will explain further in the future video. So this calculation will be the input of the sigmoid, and sigmoid will have this shape, and because sigmoid function is 1 over 1 plus a minus a, and a will be the input in this case. So I think you guys may heard a lot about cross entropy, but here I will derive cross entropy. There's many ways, but this is the view from the discriminant and logistic regression. As I told you before, the probability yn can be represented as P, the one given input data. So this data will be represented as like this. Here is the basic assumption. It should be IID, identically independent distribution. So each data point should be independent. So, and if target is 1, which is true, then the probability will work, and it will be just 0. It will be 0, so we can neglect the red term. But if target is 0, which is wrong, then we can neglect this probability. So our prediction is wrong, so the opposite case will be correct. So only this term will remain. So every point will be individually multiplied here. So we want to maximize this probability. This is our goal, because we want to increase our probability as high as possible, because that means we predict really well, our model will predict well. So I will define error function as the negative log likelihood, because log likelihood has this shape. So if we minimize this negative log likelihood, that means we can maximize the probability, our original function. So error function will be the function of weight, and it will be log minus log the probability, and it can be written as, because all of multiplication will be just summation when the log is, I think you guys will know, but I will just explain. AB will be log A plus log B. That's why we prefer using log. It make the mathematics really easy. Here Tn log Yn plus 1 minus Tn log n 1 minus Yn. I just move this equation to here, this equation to here, and Tn comes out from the log. So now I finally calculate this cross entropy. But when you're calculating gradient descent, it is also important to calculate the partial derivative of error function. So it is a really nice model to calculate the partial derivative. I will explain right now. Tn, because of log characteristic, I can write it down. Here, okay, and with Tn like this. I think here we don't have any problem to follow up to this part, and I will expand this equation. N Yn 1 minus Yn multiply basis function, because the derivative of sigmoid is sigmoid 1 minus sigmoid here, but before we used basis function as input, so we still have one more coefficient in terms of weight, so we have this basis function as well. And I can write it 1 minus Tn again. Here it is minus, I will explain again. 1 minus Yn 1 minus Yn, like this. But because there is minus sign here, this minus sign goes to this minus. So here we can delete this each equations, and it will be Tn minus Tn Yn minus Yn plus Tn Yn basis function, and like this. So these two terms will be also cancelled out, so you can feel things are getting easier right now. So the end equation will be this minus went inside So we can write it like this. So this equation is really simple to calculate delta rho gradient descent, so it's really nice. In the next video, I will further explain about gradient descent, and there's some kinds of method using the rules, so I will keep moving on. Thank you for watching my video.